right, so we are moving into chapter 6 today. So chapter 6 is all about expressions. Does anybody know what an expression is? Or have an idea what an expression is? So basically, an expression is an equation without the equal sign. So like 2 plus 3, that's an expression, okay? Or x plus 3, that's an expression. Okay, there's no equal sign because you're not actually solving for anything. You're just writing it out. And it, like a numerical one, we can solve. Okay, 2 plus 3, we know. But when you have a variable like this x, that's where things get complicated. Okay, so down here it says math in the real world. Sailboats can travel at a cruising speed of about 6 knots in a recent race from the United States to the United Kingdom. A racing sailboat traveled at an average speed of 25.8 knots. Use the bar diagram below to find the difference between the cruising speed and the racing sailboat speed. So what does difference mean? What does difference mean? Zach?
It's different from math.
I'm talking about for math, though. Subtraction. So we would take the 25 and 8/10, 25.8, and we're going to subtract 6 away from it because we're trying to figure out how much is left, the difference. So we subtract 6. Now, do I put 6 underneath the 8, the 2, or the 5?
5.
The 5, because that's a ones place. So technically there's a decimal after the 6, and we can annex a 0. So now we just subtract. What's 8 minus 0? 8. Okay, we bring our decimal point down because we know that we have to line them up. Well, we can't do 5 minus 6. So we got to borrow. And then what's 15 minus 6? 9. And then just 1. So 19 and 8/10. 19.8. All right, we're going to jump over to page 433 once you have that.
433?
433. All right, so the lesson 1 of chapter 6 is all about powers and exponents. Does anybody know what an exponent is? What's an exponent? Anybody know? All right, well, we're going to get right into it. Maybe. All right, so down here in the vocabulary startup, it says a product of like factors can be written in exponential form using an exponent and a base. So the base is the number used as the factor. That's the number that's getting multiplied over and over again. Okay, so if you have like this right here, 10 times 10, 10 is the one is the base. It's the one being multiplied over and over. Now the exponent tells us how many times we're actually multiplying that number out. Okay, so down here it says, well, they want you to fill in the words factors, exponent, and base. So right here, okay, what would these be? Factors. What would this one be? The 10 right here by the 2. That's the base. And then what's the 2?
The exponent.
The exponent. Okay, so the factors mean those are the numbers that we're multiplying. The base is just making it easier on us because we only have 1 now because it's the one that's being multiplied over and over again. And then the 2 is the exponent because there's 2 of them. Okay. Can anybody give an example of an exponent? Just like this.
2 times 2 is 4, so the factors is 2 and 2, and then the base is 4.
Not quite.
Oh.
Okay, so an exponent would look something. So here's 10 squared. That's how you say that. 10 to the second power or 10 squared. Or you could have done 3 to the third power. Or even 4 to the fifth power. You can do whatever number they give you. You can even do negatives as an exponent. which we're not going to do that this year, but you can. No, you can. Okay, now it says write the definition of exponent in your own words. Go ahead and write it down in your own words. Okay, so look back up at the definition at the top. Do not copy that. That's not your own words. I want your own words. So I'll give you about a minute or so. Go ahead and write it down. All right, so basically I just wanted you to come up with your own definition of exponent in your own words. Okay, now down here in the real world link, man. MP3 players come in different storage sizes such as 2 gigabyte, 4 gigabyte, or 16 gigabyte. Okay, which GB means gigabyte. So 1 gigabyte is equal to 10 times 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 10 bytes. What is the number written with exponents? Okay, this is the reason why we use these, because if you have to write that out over and over and over again, it's going to get very old. It's very long. There's too many numbers. So what would the exponent look like? How many are there? No. 9. What's the base? What's the number that's being multiplied over and over again? 10. So we would put 10 as our base, and our exponent is 9 because there's 9 of them. That's how these work. So once you have that, go ahead and go on to the next page. All right, so we are going to write products as powers. What that means is numbers expressed using exponents are called powers. So that's what they're referring to. Whenever you use an exponent, it's called a power. So for example, 100 is a power of 10 because it can be written as 10 squared. Numbers like 100 are called perfect squares because they are the squares of whole numbers. So in the back of your book or in the front of your book, there's a few pages, mainly in the back. Okay, there's like blank pieces of pages. I want you to go to those now because we're going to write out a few things. Okay, we're going to talk about the perfect squares. There should be like some blank pages somewhere.
On the very end.
Yeah, right there. Your hand's on them. Nope, no. Right below your hand.
Oh,
That's a blank piece of paper. Okay, so these are called the perfect squares. Okay, what I mean by this, they take all the counting numbers that we normally work with and use exponents with them. So basically what I'm saying is 1 times 1. These are the perfect squares. What's 1 times 1? 1. Okay, 2 times 2. No, 4. Okay, guys, you're literally using the same, you're multiplying the same number together. So these are perfect squares because there's only 2 of them. So like 1 times 1, that would be 1 squared. 2 times 2, that means 2 squared. 3 times 3, 9. Guys, you should be writing these down. These are the perfect squares. You're going to need to know them. Okay, it's going to make life a lot easier if you have these. Okay, 4 times 4. 16. 5 times 5. 25. Okay, 6 times 6. 36. 7 times 7. 49. Guys, if you notice a pattern, I'm going 1 through 10 basically right now. And you're just multiplying it by the same numbers. All right, now 8 times 8. What would that be? 64. 9 times 9. 81. 10 times 10. 100. Okay, so these are the perfect squares. All right. Basically what that means is you took the first 10 whole numbers and multiply them by each other. Okay, that's what exponents are. You're literally multiplying the same number by each other as many times as the exponent's telling you. In this case, there's only 2 of them. So what would be our exponent? 2. If there's only 2 of them, we only use 2. Okay. Now let's keep going. I'm going to keep, because they'll use these 2. 11 times 11. Anybody know that one?
111.
Nope. 121. Nope, sorry, Kim, I didn't see your hand. Okay, what about 12 times 12? Anybody know that one? Zach? 144. Anybody know 13 times 13? Anybody have a guess? 169. I can't remember what 14 times 14 is. I want to say it is 216. So 14 times 14. Let me double check that.
I think that's right.
Oh, 196. Man, I'm off my game. And 15 times 15. Anybody have that one? That's one I remember.
Is that 192? 192.
You're close. 225. Okay, so these are the perfect squares 1 through 15. We won't go any higher than that. So those are the perfect squares. Now, you need some more room because the next one, I'm going to erase those, is going to be the perfect cubes. Okay, what I mean by that, actually, yeah, we're going to go ahead and do those. So the perfect cubes, does anybody have an idea how many of those are going to be? No. How many numbers are we going to multiply together? 3. So perfect cubes are like this. So 1 times 1 times 1. See, there's 3 factors. So what's 1 times 1 times 1? 1. 2 times 2 times 2. Yep. No, it's 2. It's 8. Because you do 2 times 2 would be 4 times 2. So it's not 2 times 3. That's why I'm glad you said that, actually. Okay, so this would be written as an exponent, would be 2 to the 3rd power, or 2 cubed. Okay, there's 2 ways of saying those. Okay, usually you just say 2 to the 3rd power. Now, this does not mean 2 times 3. Okay, it means that this factor of 2 is being multiplied 3 times. So 2 times 2 times 2. Okay, that's how exponents work. That's what you just got to remember, which we'll get into that here shortly. Okay, now 3 times 3 times 3. 27. Because you got to think, 3 times 3 is 9, times another 3, 27. Yep. Okay, now 4 times 4 times 4. Oh, think about this. So what's 4 times 4? Times 4 is 64. So these are going to go up a lot faster. Okay, 5 times 5 times 5. Close. No, I was talking to Kylie. 125. Just think, 5 times 5 is 25, times another 5, 125. Okay, 6 times 6 times 6. This one I can't remember. That's the 216 I was thinking of. Okay, 7 times 7 times 7, 343. And I haven't done these in so long that I can't remember them. Because I didn't do them last year. $512. And I used to be able to name these off the top of my head. I'm pretty upset with myself, I'm not going to lie. 9 times 9 times 9 is 812, I believe. No, that ain't right. 729. And 10 times 10 times 10. This one I do remember. Does anybody remember or know this one? 10 times 10 times 10. 1,000. All right, so those are the perfect cubes because there's 3 of them. Okay, perfect squares means there's 2. You're multiplying 2 numbers together. Cubes mean 3. Okay, so if you look, they're showing you like this. So the perfect squares look like 10 times 10 to the second power, which equals 100. We already talked about those. Okay, so you're going to want to keep those handy because they're going to make things a lot faster and a lot easier for you, especially if you start memorizing them. Okay, that they just make these problems go a lot quicker. So now, what we're going to be doing, okay, now, example number 1 here. They're just going to give you basically an expression, a numerical expression. They want you to write it using an exponent. So we have 6 times 6 times 6 times 6. So what would be our base? Oh, 6, because that's the number being multiplied. Now, how many are there? 4. So our exponent is 4. That's it. That's all they want you to do. All right? For right now, that's all they want you to do. For right now. Okay? They just want you to write it using the exponent. They didn't say anything about solving it. They want you to write it. Okay? So like this one. Number 2. They say write 4 times 4 times 4 using an exponent. So the factor is what? 4. The factor is multiplied how many times? Stevie? 3. So what's our exponent? What is it? Just say it. No, what's our exponent? Just the exponent, the small number. 3. So this can be written as 4 to the 3rd power, or 4 cubed. There's 2 ways of saying 2. When you have a 2 up there, right here, if your exponent is 2, it can be read as 4 to the 2nd power or 4 squared. When you have a 3, you can read it as 4 to the 3rd power or 4 cubed. So whatever's up to you. Mainly, you just say 4 to the 3rd power. It's a lot easier. It's the most generic one. Okay? So let's jump over to page 437. We're going to do a couple more examples. So all the directions say is write each product using an exponent. So we're not solving it. We're just writing them using exponents. So number 1, 6 times 6. So what's our base? 6. What's our exponent? 2. So your exponent's always a small number. All right, it goes right there above it in the right-hand corner like. Okay, number 2. 1 times 1 times 1. What's our base? 1. What's our exponent? 3. Okay, number 3, I mean. 5 times 5 times 5 times 5 times 5 times 5. What's our base? 5. What's the exponent? 6. That's it. That's all they want you to do right now. We're not solving these. We're just writing them out. All right, so I want you guys to go back, and I want you to do A and B back on page 434. So all you're doing is writing it with an exponent. So figure out your base and figure out how many there are and go from there. So A and B. All right, here we go. So letter A, we have 7 times 7 times 7 times 7. So what's the base here? Who can do letter A? Stevie.
7.
Okay, the base is 7. What's our exponent? 4. 7 to the 4th power. That's how that's read. Okay. The letter B, 9 times 9 times 9 times 9 times 9 times 9 times 9. Kylie? To the power of 7. 7th power. Okay. Any question? Okay, that's all it. So that's all exponents are, guys. You're not multiplying these two. You're not doing anything like that. You're literally just setting up how many there are, and that's your exponent, and whatever's being multiplied is your base. It's as easy as that. Don't overcomplicate this. All right, now on the next page, what they're going to do is they want you to write, they're going to give you an exponent, and they want you to write it out like we just, so before we had 5 times 5 times 5, we wrote it as an exponent. Now they're going to give you 5 to the 3rd power and want you to write it as 5 times 5 times 5. Okay, so you're just going the opposite way now. So it says number 3, write 5 squared as the product of the same factor. Basically what that means is they want you to write it out. So how many, what's our base? 5. How many do we have? 2. So we were basically doing 5 times 5. Then they want you to solve it. Okay, so what's 5 times 5? 25. There's your answer. Right there. Okay. So number 4. Okay, it says write 1.5 cubed as a product of the same factor. Okay, so basically what you're doing now is doing, what's our base? Not 1. 1.5. How many times are we multiplying it out? 3. So there's going to be 3 of them. So then you multiply those out, and you get your answer of 3 and 375 thousandths. So all you're doing is, guys, all exponents are multiplying. That's it. All we're doing this entire lesson is multiplication, basically. Okay, now when they have a fraction like this, you're still just writing it out. Your base is 1/2. So it's literally 1/2 times 1/2 times 1/2. So let me just walk through it. So when we do multiplying with fractions, you multiply the numerators, then you multiply the denominators. What's 1 times 1 times 1? 1. 2 times 2 times 2. 1/8. That's your answer. Okay, that's all you have to do with fractions. It doesn't change anything because remember, we know how to multiply fractions by doing the numerators together and the denominators. So let's go back over to page 330 or 437 again. I'm going to do a few more of these. Okay, number 7. All right, they say write each power as a product of the same factor, then find the value. So number 7, we have 6 to the 4th power. What's our base? 6. How many times are we multiplying it out?
4 times.
4 times. So 6 times 6 times 6 times 6. Okay, when you have numbers like this, what I like to do is group them together. It makes things a little bit faster. So what's 6 times 6? 36. What's 6 times 6?
36.
36.
No.
Now all you're doing is 36 times 36. Makes it a little bit easier. Okay, so 36 times 36. 6 times 6 again? Okay, we carry the 3, so 6 times 3?
12.
6 times 3, guys.
18.
18 plus 3? 21. Okay, so now I come down, I put a 0. Now we're on to the 3 times 6. 18 again. That's a 1. 3 times 3? 9 plus 1? 10. So we add this up. We get 6, 9, 2, 1. 1,296 is your answer.
Big numbers.
Okay, number 8. Okay, we have 1/2 0.5 cubed. So what's the base? 0.5, so 1/2 times 0.5 times 0.5. So then all you're doing is multiplying this out. Now remember, with multiplying with decimals, you have to add it in at the end, because all you're actually doing is how many decimal, you move it, how many decimal points there are. So how many, if we're going to multiply these two together, these first two, how many numbers are after the decimal in this first one? How many numbers are after a decimal?
5.
No. How many numbers are after a decimal in this one right here? 1. How many numbers are after a decimal here? 1. How many numbers are after a decimal here? 1. So, real quick, I know that I can multiply 5 times 5, which is what? 25. Now, since I multiplied those two together, I know I have to move the decimal how many times? 2. So we move it to the left. 1, 2. So we have 0.25, but we still have one more we got to multiply it by. So now I know that how many numbers are after the decimal here? How many numbers are after a decimal, guys, in this one, this number right here? Okay, guys, it's not a guessing game. Here's our decimal point. How many numbers are after the decimal point and that number right there? 2. 1, 2. So then now I got to multiply it by this, so I know at the very end I have to move it 3 times. So 25 times 5, basically. So that would be 25 again, 10, 12. Now, I know I have to move it 3 times, so my answer is going to be 0.125. So this is all about multiplication, guys. So that's a decimal. So there's nothing different there. You just have to multiply it out and follow the rules of decimal multiplication, which we've done in the past. Boys, you guys need to start taking some notes. Sit up, take some notes. Okay, number 9, 1/8 squared. So our base is 1/8, and I know since our exponent is 2, we're multiplying just 2 of them. So 1/8 times 1/8. Now, since we're multiplying 2 fractions, I know we multiply the numerators, then we multiply the denominators together. So basically, what's 1 times 1? 1. What's 8 times 8? And there's your answer. All right, I want you guys to go back and do C, D, and E back on page 330 or 435. So write them out, then you solve them, just like we just finished up. I'll give you a couple minutes. Go ahead and get to work.
1 times 2 is 2. Then 2 times 2 is 4. It's 4 times. And then you add these two numbers to get 6. But since you have these two decimals, you have to start over here and go 1. And move over 2.
All right, so it says write each product or power as a product of the same factor and then find the value. So basically, all you're doing is writing these out and your expression and solving them. So if it's 10 to the 5th power, how many 10s do we have? Camden? 5. So it's literally 10 times 10 times 10 times 10 times 10. Okay, I like to group them together. It makes things a lot faster and a lot easier. So I basically do like 10 times 10 and then we'll group that in later. So what's 10 times 10? 100. 10 times 10? 100. Then we'll just group that one there. Now, does anybody know what 100 times 100 is? Close. 10,000. Times 10. So now we got to multiply it again. So 10,000 times 10. Guys, just add a 0. 100,000. So there's your answer. So you got to have this all written all the way out plus your answer. Okay, so now letter D. Okay, 2 1/10 squared. So this is literally 2.1 times 2.1. All right, that's all that means. So now that's part of it. Now we got to multiply this out. So we're literally just multiplying 2 1/10 times 2 1/10. Okay, at the very end, we got to look to see how many times we're going to have to move that decimal. How many numbers are after a decimal in this number? 1. Guys, here's my decimal point. How many numbers are after it? 1. Okay, same thing for here. How many numbers are after the decimal? 1. So at the very end, I know I have to move it 2 times because we add those together. So now I multiply this out. What's 1 times 1? 1. 1 times 2? 2. Okay, so I drop down, bring a 0. 2 times 1? 2. 1 or 2 times 2? 4. Now we add this up. Running out of room. Okay, and now I know I got to move my decimal how many times at the end? 2 times. So I start here at the very end. I go 1, 2. So my decimal goes right there. So 4 41 hundredths. And you got to have this as well. So 4.41. Okay, now we're going to do the fraction. So 1/4 times 1/4, because there's only 2 of them. So now I know I just multiply the numerators. So what's 1 times 1? And then I multiply the denominators. 4 times 4? 16. So you got to have both of this. Okay, 1/16. Any questions on this? Guys, write them out every time. That will make your life easier. Then you just know you got to multiply them out. That's it. And one more example on the next page. Okay, so you're also going to see some story problems. Nothing out of the ordinary. It doesn't throw anything out. It's just literally talking to you about exponents. So the zoo has an aquarium that holds around 7 to the 4th power gallons of water. About how many gallons of water does the aquarium hold? Well, so all you got to do is write it out, multiply it out, solve it. That's all they wanted you to do there. Okay, if they're asking you for how many gallons of water in this case, they're asking you to solve it. That's the only thing that they got going on a story problem. It doesn't change anything about exponents. It's just literally solve it out. Okay, any questions? All right, your homework is on IXL under section D. So 6th grade math, section D. And it's going to be 1 and 2. And I will go start those real quick. So remember, make sure it's in 6th grade. A lot of you guys are still all over the place with that. Section D.